We are on the verge of wrapping up chapter 4. Let's talk really quickly about something cool, the rule of 72. It's the rule for doubling your investments. So let's say that we're compounding continuously and we want to see how long is it going to take for the thing to double. So as you know, the rule is A equals P e to the RT, right? And we want to know how long is this going to take to double. Well, that means that if we divide by p, like we let p be 1, then that means a is going to be 2. So 2 equals 1 times e to the rt. So how long is this going to take? Well, as you know, we now take the natural log of both sides. So natural log of 2 equals the natural log of this, which means we just have r times t. Okay, well that's pretty nifty. Let's see, let's divide both sides by r, because we want to see how long this is going to take. And we get t is equal to the natural log of 2, and I'm going to go ahead and find out what that is. 0.693 divided by r. Now, r, remember, is an interest rate. So it's 0.01 for 1%, right? So let's multiply the top and the bottom of the fraction by 100. And we get 69.3 over 100r. And this is really cool because this means that, say your interest rate is 3%, if you just need to do 69.3 divided by 3, and you're going to have a really accurate approximation of the amount of time it's going to take for something to double. Now, why is it the rule of 72 instead of the, so in other words, just do 69.3 divided by your interest rate, and if it's 3%, then just plug in a 3, or if it's 4%, plug in a 4. That's pretty close, but the reason it's the rule of 72 is 69.3 is really good if it's continuous. If it's not continuous, if it's compounding monthly or yearly, then 72 over r is better, and especially if the interest rate is around like 5, 6, 7, 8%. So in other words, if you invest $1,000 and you're earning a 4% interest rate, then just do 72 divided by 4. It's going to take you about 18 years for that to double at 4% growth. Really easy calculation. So here it is for continuous, and here it is for non-continuous, like compounding every month or so. So let's find the exact answer. We want to see the growth of 5% compounded yearly, and then we'll compare it to the approximate answer. So we're compounded yearly, so A equals P of 1 plus compounded yearly. Our interest rate is 0.05 over 1, and this will be if we're compounding yearly. This will also be a 1 up here times the number of years. So we're doubling, so again, let's plug in 2 and 1 for A and 1 for P. You get 1 plus 0.05 to the T. Okay, so again, our initial investment was 1. We want to double it to get 2 over here. Our number of times compounding was 1 and an interest rate of 0.05. Take the natural log of both sides. I kind of skipped a step there. Make sure you understand what I did. I took the natural log of here, and I took the natural log of all of this, which meant that the t can come around front. Okay? So let's do that. Let's do divide both sides by the natural log of 1 plus 0.05. T equals, let's do it. The natural log of 2 is 0.6931 divided by, I'm going to do 1 plus 0.05 equals that. Take the natural log, 0.04879. All right, so let's divide 0.6931 divided by 0.04879. And we get that it'll take approximately 14.2 years to double. So that was a lot of work. So maybe there's a shortcut. Well, 5% compounded yearly. Let's use the rule of 72. 72 divided by my interest rate, which is 5, gives us an answer of 14.4. So you can see that that's pretty close if you just do 72 divided by your interest rate. And again, the reason that works is because 72 over r is approximately equal to the natural log of 2 divided by the natural log of 1 plus your interest rate. So that's why these two numbers are so close. Just do 72 divided by your interest rate, and you get pretty close. But if you want to find the exact answer, you need to do this one. So let's do this last one. The doubling time for an investment earning 7% interest, it's compounded continuously. So A equals PE to the RT is continuous compounding. How many years will this take? All right, so we want to know how long it'll take to double, so just plug in 2 and 1. Our interest rate is 0.07, and then we have a t right there. So this simplifies to 2 equals e to the 0.707t. Take the natural log of both sides. You get, I've done this so many times I almost have it memorized, 0.6931. Yep, 6931. Natural log undoes e, 0.07t. Divide by 0.07. Divide by 0.07. So that divided by 0.07 is approximately 9.902 years. So that is the doubling time, 9.902 years for this to double. If you know the shortcut, you just take 69.3 and divide it by 7. And you get 9.9, which as you can see is really close to 9.902. And you can see the 0.6931 there. That's why we use 69.3, because you times them both by 100. So these are two little shortcuts, this one for continuous, this one for regular compounding over a regular interval. And you can see that you get pretty close without having to do all the natural log math. So if you want to do the exact answer, you need to do the math, but this is a good back of the envelope thing you can do. So I think I'm going to stop this video here. We have one page of examples to go, and then we are done with Chapter 4. So I will see you in the last video for Chapter 4.